Hey, here we are, lesson 13, side-splitting and mid-segment theorems. This is also going to be lesson 14, you'll see in a second. Right now I'm listening to NSYNC. Don't know if you can hear it or not, but you're lost if you can't. So go ahead, read the problem, pause it, draw a picture associated to it, yada yada yada, y'all know the drill. Alright, we're back. At the same time, we got the shadow going on, standing next to it. One of your ratios, if you decide to set up proportions correctly, should have been 5 over 8 equals x over 55. Again, not all of them are going to look alike. There's probably like 4 different ways you could have written this one. But ideally, the same result should happen. You should be getting about 34. Where's my marker? Boop, boop, boop. Should have gotten 34-ish. Had that feet on that flagpole. Again, I'm not sure if that's even standard for flagpoles, but I'm not a flagpole salesperson, so I don't know. Bleep. Boop. Bop. Why does this not work? There we go. Oh, button is stuck. Oh, stop. There we go. So, copy the proof down. Again, if triangle ABC is cut by a line DE, it's parallel to BC, that's given. And we're trying to get to the proof that ADE is similar to ABC. So as you can see by the statements, copy down what's given. ADE is congruent to ABC. Notice their location. That's corresponding angles we got going on right there. Okay, so with all that in mind, to finish off your proof, first reason is going to be given. Corresponding angles are congruent for number 2. And 3 is going to be angle. So again, this would be a perfect time to pause the video so you can copy this down. Now, like I said in class, these proofs can be as long as like 8 statements or 10 statements with reasons to back them up. So I'm about to show you an example. Again, don't worry about it too much. It's just me explaining how we come across some of these theorems. So, to continue on with this idea, if you want to, you can keep adding, or you may need notebook paper for this. Let's take this proof a little further. Now that we have angle, AD, AB is equal to AE over AC is equal to DE over BC. Again, that's that similar triangle idea we've been discussing earlier. Those sides should be proportional to each other. Definition similar polygons. Keep going. We start digging into the rest of this proof so we can work up our theorem. So notice, if I do AD plus DB over AD and BE plus EC over AE, again, we're adding segments together, so segment addition postulate. Okay, then we distribute the division here. As you see, we split it up. Okay. Well, anything divided by itself is 1. So replace that with 1. And then we subtract the 1, subtract 1 from both sides. Then we're left with dB over AD equals EC over AE. Okay, again, not too bad. Y'all have seen these properties before. This leads us into our side-splitting theorem. A line parallel to one side of the triangle divides the other 2 sides proportionally. And again, literally a handful of ways you can write this when it comes to solving for side lengths. Okay, upper left, upper right, lower right, etc., etc. Okay, I like to tell students they're practically set up as a fraction sometimes. If you were to just put huge little fraction lines here, dadgum, this thing will just never go away. Okay, but you'll see that in an example. So, use the side-splitting theorem to find the value of x. So go ahead, get yourself up a proportion. Go ahead and pause the video. Okay, that's already wrong. Again, daylight savings time and whatnot. Bleep. C, one way you could have set it up is literally writing it as it is over each other, like I discussed on the last page. They're practically set up as fractions. So 15 over x equals 12 over 16, cross multiply, divide by 12, bloop, blop, boom, you should have got x equals 20. Okay, let's try another one. You may have to rotate your paper, move the triangle around to get a nice little setup. In fact, there's two ways you could probably set this up. So go ahead and pause the video and give it a shot. While you're doing that, I'm going to color my coloring book. Nope, just broke the lead. I guess I was never meant to color. Alright, we're back. Complete. So 3 over 2 is one way you can set it up. And this could equal 7 over x. Where did that 7 come from? That's right. 3 plus 4 is 7. It's the whole side. Okay. Another way you could have set it up was 3 over 2, 4 over x minus 2. X minus 2 came from right here. X minus 2 would be this piece, since x is the whole thing. Again, there's several different ways to set this up, but notice, as long as you keep things consistent, you should get the same answer. Alright, let's try something else. Bleep. Again, here we have a triangle made with transversals and parallel lines. And as we can see, ADX is similar to BDY. Again, over angle-angle postulate. Because all of these are corresponding angles, so they have to be congruent, and they're all sharing this one vertex angle. Okay, so with that being said, in your little blank notes, you should have two transversals. Excuse me, I think I was about to sneeze. There are more than parallel lines divided two inter. Hello, I don't see it. I guess I'm yelling. I know it's in the middle of the afternoon, but I woke up too early because I forgot to change my clock. Anyway, example. Again, you can have AB over BC, XY over YZ. So you want to jot down that example into your fill-in notes. And we're going to use this idea to solve these next proportions. Bleep. So go ahead, try these out, set up good proportions. Again, they're practically set up for you. I'm just going to put one right here, and I'll let you do the other. 62.5. Oh, good gooey moly. I wrote decimals in the wrong spot. 6. Still put, I'm just going to put the 2 over it. Boom, nailed it. Should equal y over e. That's one way. Set up the other way after you solve for y, whatever floats your boat. Again, y'all are getting better at this cross multiplying. Swoosh, swoosh. Solve, and yes, you should have gotten x being 51.2-ish, and y should be 64. Again, if you set your proportions up, if you didn't get the right answer, go back, make sure you got things set up right, okay? That was that chicken basket I had earlier. Boop. Again, setting up theorems and proofs. Given triangle ABC cut by segment DE such that AD is congruent to DB and AE is congruent to CD, prove that DE is parallel to BC and that DE equals half of BC. So here's another example of a proof. Okay, for those of you who want to, venture out and try it, go ahead and pause the video. Okay, we're back. Let's go over the reasons. Click. There we go. So, obviously, number one's given. We use SAS, side angle side for the similar triangles, and due to that, corresponding angles of similar triangles are congruent, so that's why AD is congruent to ABC and AED is congruent to ACB. With that bit of knowledge, the fact that those are corresponding angles, well then that means we have parallel lines because they're cut by transversal that are congruent. So DE should be parallel to BC, again because of corresponding angles. When we look down at 5, definition of midsegments. Okay, AD is congruent to DB, so that's, we got this idea of the AB being cut in half. So corresponding sides of similar triangles are proportional, which leads into the fact that DE should be half of BC. Okay, I know this is a bit hard to follow, but I don't think, EOC or anything like that's going to ask that hard of a question. I'm really thinking it's just going to be something easy like alternate angles, corresponding angles, reflect, just nonsense like that. But anyway, that gives us our next theorem, triangle midsegment theorem, which again tells us essentially that DE and BC are parallel. DE should be half of BC. Again, if it's midsegments, okay, that's important. If it's midsegments, DE is parallel to BC, and DE should be half of CB and BC. Okay, so pause the video, draw a picture if you need to. We have an example here in a second. Blue. So XY is the midsegment of ABC. BC is 30. Again, label this stuff. BC is 30. We just said it should be half, so our answer should be 15. Half of 30 is 15. And if we went the other way, EF is 12.5. Again, pause the video if you need to so you can copy the picture, but you just double it and we get 20. Go back. It's 25. Working backwards times 2 to both sides, it's going to be 25. So make sure we have these tick marks. Make sure it says it's congruent or this falls apart. Okay. In addition to the fact that DE is half of BC, what else about these two segments Again, DE is parallel to BC. We said that before. Okay. Blue. So if that's the fact, then DE is a midsegment of ABC, then we can say AD is 7 and AC is 20. What are AB and EC? Easy. If AB is 14, then that means AD should be 7. DB is 7, you're just doubling it. EC is 10, again, double it, we get up to the 20. Boom, bam, bam. Easy peasy, lemon squeezy. Again, if you wanted to write, remember AC is 20, and they told us AD was 7, so you're essentially doubling it. Okay. Whoop. TU is a midsegment of triangle XYZ, so angle X is 100. And X, TU is 45. What's the Z? Again, putting angles where they belong. These are corresponding. Should be 35, which makes this 35. Okay. Again, pause the video as you need to. Jot down the notes as you need to. We'll skip that. And we'll skip that. Past that. Now it's just doing the warm-up, which again, answers are provided on the Google Classroom. But watch out for little tricks like this. This should be 10. Because if the whole thing's 14, well, 10 plus 4 is 14. Look out for stuff like that. You may want to rewrite some of these triangles to figure stuff out. For example, this is an X. So this base would be X minus 25. So look out for stuff like that. Okay? Same thing with this little segment. What's 24 minus 15? Remember, the trick is to count up. 9, that's right. Because 9 plus 15 should be 24. So use little tricks like that to set up good proportions. Now, half this homework is from lesson 14, so I'm going to go ahead and hop on over to that one. Ooh, it's time to learn. Let me go back to the beginning. Bleep. We had this discussion in class about all isosceles triangles similar. Y'all gave up some reason, yada yada yada. And then I asked about the right triangle. She'll say yada yada yada. So give some counterexamples. So as we discussed, both answers were no, because equilateral triangles are technically isosceles, but as you can see, their angles don't match. Well, I mean, all the angles are congruent here, but when it comes to similar, well, we have two isosceles triangles here, but as you can see, they're not similar. Angles could vary. Again, going back to that same shape idea. Same thing for right triangles. That same shape idea. We have 45s down here, and this one is 3060. So good counterexamples to be thinking about when someone asks about, are all certain triangles similar? But, we had a good discussion about that in class. I got to solve problems using triangle similarity. All right. So, are these two triangles similar? How do you know? I know right off the bat they are, because we have two right angles, and as we know, vertical angles makes these congruent. So yes, these two triangles are similar, which means their sides should be proportional to each other. So quick little setup. Angle. I did 30 over 40, 65 over x, cross multiply, solved. We get 86.67. Remember, pause the video if you want to try these out. For example, this one. Pause the video, give it a shot. Alright, now that we're back. Again, the idea is we got reflexive angles up here at the vertex A. 90s means these triangles are similar because of angle. And another way to think about it is, if we look at the big triangle, this is going to be x plus 25. And again, the slate, no wonder, because Google Drive is slowing me down. Keeps popping up saying I don't have space, but I should. In fact, I might pause the video to turn that off. Hey, we're back. I turn it off. Let's see what happens. Anyway, here's one way to set it up. For sharing angle A, like I discussed. So triangles are similar by angle for similarity. And again, here's one way to set it up. And to solve, we get 125 for x. Okay. All right, let's look at something else. Proportional altitudes theorem. We're going to fly through these real quick. Again, keep your fill in the blank notes handy, and again, pause the video when you need to. If two triangles are similar, then their corresponding altitudes have the same ratio as the corresponding sides. Oh boy, why did I do that? So here's some examples of altitudes. Remember, it's the height of the triangle. They could be on the inside, could be on the outside, could be a side, and these are called right triangles. Okay, again, pause the video as you need to. We're going to try to fly through this, keep this video short. Bloop. Again, set of proportions. There's like a multiple of proportions. I think we had all sorts of in class. As long as you keep things corresponding, should be fine. So one example is 6 over x and 9 over 5.25. Cross multiply, we get 3.5. Okay, and there is another correct way, and we discussed those. In fact, I don't even think this was the way we did in class, but this is another way. Boop. Again, trying to fly through these to keep the video short. A median is a segment from a vertex to the midpoint of its opposite side. And when you're doing your construction books, you'll learn that when all the medians connect, that turns into the centroid. Point of center would be the centroid. So, proportional medians theorem, if two triangles are similar, then their corresponding medians have the same ratio as their corresponding sides. Again, the median is this dotted line. Midpoint to the vertex. Boop. Again, set up your own little ratio. Pause the video so we can compare answers. I think like saying killing me. I don't even know if my computer clock is right. No, my computer clock is right. So is my phone. Boop. So 4 over x is one way to do it. 5 over 7. Cross multiply, we get 5.6. Okay, and again, we did discuss other ways to do it in class. To recap, remember, dissect means to cut. As when you dissect a frog, you cut the frog in half. Bi means two, as a bicycle, two wheels. So when we put two together, we cut something in half. So bisect means to cut into two equal parts. Again, this is part of your fill in the notes if I'm not mistaken. Again, this was a review. Since it's around Halloween, never mind, I won't talk about cutting people in half. Like a frog. Boop. Proportional angle bisectors theorem. Forgot, this is the angle symbol. If two triangles are similar, then the corresponding angle bisectors have the same ratio as their corresponding sides. If you haven't gotten the pattern yet, but yeah, a lot of things have the same ratios. Again, pause the video, try to set up your own proportions. Alright, we're back. Here's mine. We did 4 over 6, x over 9, cross multiply. We should have gotten 6 for x. Again, there's other ways. We talked about them in class. Or try to find other ways. But regardless, the answer should be 6 no matter which one you set up, provided you set it up correctly. So, I think we skipped this in class. We'll do it together. You are 5 feet tall, as the diagram shows us. Standing outside the sunshine, your shadow is 8 feet long. At the same time, the shadow of the nearby tree is 24 feet long. How tall is the tree? Hint, make a sketch. I already made the sketch for you. I'm putting an X on what we're looking for. And it's just that easy. X over 24 should correspond to 5. Oh. Guys, I'm real sorry about the slate not keeping up with me. I'm just doing too much math for this computer to handle. Boop. Cross multiply. Trying to write an 8. 8x equals, what's 24 times 5? 120. Divide by 8. And we get 15. 15 feet. Again, the slate is just making my handwriting worse than it actually is. So it's time to learn. Do your homework. Okay, answers are on what you call it. Google Classroom. That's it. Okay, got any questions? Let me know. Have a wonderful day. Oh, forgot the part. All right. Have a good evening.